So my name is Chris Suchoski. I'm with Texas Instruments. I run our data center systems engineering and marketing team. So my team's scope is really to understand what are the broader industry trends that are affecting data center architectures. What does that mean for our customers? What kind of challenges do they need to solve today as well as over the next 3 to 5 years?
Yep.
And then what does that mean for the kinds of products that we need to develop, as well as what does that mean for the reference designs that we need to develop? Meaning that want to make sure that we're kind of in lockstep with industry trends with our customers as they're navigating these architectural shifts and giving them a means to actually evaluate new technologies that ideally streamline their development process and make it simpler for them to reach some of their time to market goals.
Yeah, which are like heavily compressed right now,
Incredibly
right?
compressed.
Yeah.
It used to be 18, 24 months, maybe 36 months, and now we're seeing less than 12-month time cycles.
Yeah, could you have it here yesterday?
Exactly.
Great. So why is that? Like, frame the central challenge of we have this incredible demand from AI workloads, and we have to scale to meet that, but we have to do it sustainably. How do customers accomplish that? Like, really set up the problem statement for us.
Yeah. So the problem statement being, how do we deliver something in a 12-month time period that meets this insatiable desire for basically compute is kind of the question. Yeah. So it's interesting. I mean, the general trends that we're seeing, as I think we've talked about, or not you and I personally, but at the conference this week, have all largely been rooted in power, right? We're seeing power demands increase really exponentially, generation to generation, and it's no longer affecting just the compute tray, right? Typically, that's where kind of the impact would start and stop, was within the compute tray itself.
And I'm assuming from TI's traditional scope, the compute tray is really a central focus of where you guys have a lot of history.
Exactly. That has been our focus historically. Yeah. And now as we start to talk about, today 150 kilowatt racks and, the next several years, 1 megawatt plus racks.
Yeah.
It's like almost a trickle up effect where there's obviously still an implication for the compute tray itself, but now it's affecting the entire rack architecture with the transition to 800 volt DC or plus minus 400 volt DC.
Yep.
It's affecting the entirety of the data center, as folks are now talking about centralized AC-DC conversion, getting rid of the 3-phase AC busways overhead, and basically routing high voltage DC or 800 volt DC throughout the data center. So it's affecting really the entire ecosystem and every building block that goes from the mid voltage grid all the way to the SoC gate that resides within that compute tray. So with that said, I think customers are becoming, it's really evolving how they're tackling this.
Yeah.
And that it's affecting the entirety of the infrastructure. It's affecting the energy storage systems so they're developing or deploying alongside their data centers to provide a means of backup energy to the system, to their infrastructure. It's opening up the door for more renewables, whether it be solar, wind, to provide a sustainable means of powering these data centers. It's affecting again the power distribution throughout the data center and the cooling that's needed for all of these chips. So it's really affecting end to end every aspect of the infrastructure.
Well, it sounds like, and I know, TI's very long history in semiconductors, like it sounds like, and I assume you guys have touch points in all those elements, but we'll get into that a little bit later. What makes AI different from your perspective, from TI's perspective?
I think from my perspective, I think we've all interacted with AI over the past, decade and a half, 2 decades, whether or not we knew it, right? Even like the simple search prompts and you're querying a website or something, right?
Google's first result is AI. If you use Google, you're using AI, right?
Exactly. But now it's just becoming so incorporated into every aspect of our day-to-day that, it's driving a, higher demand for compute. But as these models become more complex, we're seeing XPU, called XPU, power levels increase, maybe from several hundred watts in past generations to several kilowatts in current generations, in the same amount of real estate within a compute tray. So power is going up, space is not going up.
That's right.
Which is changing the entire paradigm of customers are designing their systems.
And really, in some regards, space is compressing too, right? Because you want to fill that space up with chips more than you do other devices.
Exactly.
That don't produce money.
Exactly.
Or tokens.
Anything that's not used for compute is wasted space fundamentally from a data center perspective. So
yeah, I think why is it different, right? So we have all this demand and you have this, really the focus is demand, but so what makes AI workloads different than traditional workloads other than just density?
Yeah. Other than density, I would say the aperiodic, unpredictable nature of these workloads.
Okay.
Right? If you're running a traditional like general compute cluster,
Yep.
you would have somewhat predictable workloads. If you're running simulations or some basic models, you can more or less predict what those workloads are going to look like. Obviously, it's still going to be end customer dependent. However, there's pretty clear mission profiles that are outlined.
Yeah, especially for the hyperscalers who dominate the show in a lot of regards, and like the loads are pretty homogenous.
Exactly. That doesn't exist anymore. Now it's 100% dependent upon human nature, which is not something you can predict, as history kind of has taught us. So that obviously, that has an effect on how we're delivering power, to these XPUs within the compute tray. But it's also having a massive impact on the grid, as some of the keynote speakers talked about on, I believe, Monday evening.
Yeah.
That's probably the biggest difference, is just the aperiodic, very unpredictable nature of the AI workloads.
So you guys find yourselves like moving outside. Give me a little background and give the audience a little background, because I think TI is kind of a little behind the curtain in our industry, right? You're in almost every device we use in some regards.
Yeah.
How has that changed from how you guys see the market? Like, obviously, you've been involved in semiconductor manufacturing for a very long time. You have elements of power conversion, and that has always been part of our industry in a very big way. How is that changing for you guys? What are you looking at next?
Yeah, so more than a calculator company. You didn't mention calculators.
Oh, I'm sorry. That's probably my most familiar contact point.
Exactly. I think for most. But yeah, we're one of the largest, we call it foundational semiconductor companies in the world.
Yeah.
And to your point, we have a presence in just about every product that you might touch on a day-to-day basis that has electronics embedded in it.
Yep.
I think as we look at the data center market and some of the opportunities we're working on with our customers, there's like opportunities for us to, I think, get the power as close to the XPU as possible. And I think there's opportunities for us to really take the decades and decades of industry experience that we've garnered from really the grid side. Want to steal some of the automotive experience that we've developed, specifically when it comes to 800-volt architectures.
Yeah,
Those
that
have
makes
been
sense.
commonly adopted in the automotive space.
Yep.
And now apply that to the data center market, because our goal is really to develop, obviously, products, but like more important than that is develop like system level expertise that spans from, again, every building block that goes from the mid voltage grid all the way to the XPU, so that we can make our customers' lives easier.
So how specifically, you're describing grid to gate. How does that, you being involved, TI being involved along that value chain, what's the advantage there of having multiple touch points? Because there's people that excel in certain verticals along that power structure. What can you guys do that connects those dots?
Yeah, so I think the value that we'd like to bring is obviously the industry experience component, right? While obviously focus on the verticals, we also are very broad in nature from an expertise perspective, but also from a product offering perspective. So I think we enable our customers like support across every, again, building block within that power tree, if you will, and really want to be kind of that one-stop shop where if customer A is working on a UPS and an ESS for a 1 gigawatt deployment.
Yeah.
We want to be a part of that conversation. Similarly, we would assume that there's going to be, a gigawatt of compute that's within that data center. We want to be a part of that conversation as well.
Interesting.
And believe that we, offer value in the form, again, of industry expertise, breadth of portfolio to enable our customers, to ideally come to us for really anything they might need along that journey. Ideally offering more than just a part, but a true means of providing them with a sounding board to help solve these problems as they're navigating some of these transitions in the market.
Yeah, I imagine you guys also have, as the industry is scaled outside the four walls of the data center, you already have a lot of experience outside of those four walls. A lot of the tech companies that work in the data center space don't necessarily have those elements in their portfolio or expertise that they can share with their customers. So,
yeah, absolutely. And I think that's honestly a really fun part of the job is like when we're navigating 800 volts as an example of this. Yeah. There's, a lot of customers are wondering like, how do we do this? And it's, I think, very fortunate that we have, again, experience in those adjacent markets that we can, act as a means of education to some extent to, help them kind of weigh the pros and cons of architecture A versus architecture B, the trade-offs of each, and inform them so they can, we can collectively make a decision on what makes the most sense for their particular business goal, whatever it may be.
Yeah. And you guys have, obviously a lot of experience in those adjacent markets. There's already trends and history and lessons learned in those spaces.
Yeah.
That it feels like the data center industry is in a large way just starting to learn now. I mean, obviously the big hyperscalers over the last 2 years have been doing lots of things, but there's still a lot of learning to be done in very new spaces. So with that, did you find the data center industry from a adjacent industry, or have you been data centers all the time personally?
I actually found it not even an adjacent industry. I just had an opportunity to kind of step foot into it, and it's been really fun journey.
Good.
You hear data center historically, and you think it's kind of slow moving, right? Maybe think about it as like kind of traditional industrial.
Sure.
100% incorrect. I think the fastest moving market that I've been a part of.
Yeah, same. I mean, I think one of the funnest part is like nothing's been figured out. It's all being figured out. And I like being part of that.
100%. 100%. I was actually working on like power tool designs before this, which could not be more different than data centers.
Sure. Yeah, I imagine. Yes. Yeah, very interesting. So tie it back, obviously you guys have a lot of experience at TI that can help solve these problems, but you've been part of, we were chatting at the start, you've been at OCP quite a few times. The investment from TI has increased. You guys have a bigger presence here. What about collaboration also enables you guys to serve the market better?
Yeah, well, I think that's what's, I guess, the beauty of OCP is, there's consolidation of requirements and compromise of requirements to form kind of this standardization that, we're collectively following. I think that enables us to have, better scalability from an end solution perspective, whether that, again, that's components or that is, reference designs that we're, providing to our customers as a means of giving them, a starting point for whatever they're designing for the next generation systems. And honestly, it's a great learning opportunity for us, right? Oftentimes, we can be so laser focused on executing on product development that, this gives us an opportunity to pick our heads up and look at the bigger picture and understand, where our components actually fall into the bigger picture. That makes sense.
Yeah, it makes perfect sense. I found OCP in a similar way. I worked on the power side, and for us, it was like, this is gonna sound corny, but it is definitely like you can go see where the puck is gonna be, right? From the hockey adage, like if an adjacent segment of the market is making a major change and you're impacted by that, it seems like this is a good place to see where those impacts may fall.
100%. This time last year, I think they announced Mount Diablo, right, for the 800 volt architecture, and we have proof of concepts now demonstrating that this is real, it's coming, it's happening. And to your point, it gives you like a 12-month advance notice of, what we need to be ready for. Yeah,
absolutely. Mount Diablo is a great example for that.
Yeah.
Looking forward, looking forward, I think we wrote down, let's look forward 10 years. But I think that's incredibly difficult to do, especially in the AI age. It's hard to know what's going to happen in 8 months.
Yeah.
But what do you see as far as power architectures changing? How does that impact the market? What do we need to be prepared for?
Yeah, it's funny you mentioned, I used to say, customer challenges are the next 3 to 5 years.
Yeah.
And I've changed that to 12 months because my crystal ball has very, very low resolution beyond next week, to be perfectly frank. However, we saw the Gen 1 12 volt architecture, transition to Gen 2 48 volts. It took roughly, 10 to 15 years to make that transition. Now we're seeing, say that major deployments started in 2022 for Gen 2 is, I think that's accurate, plus or minus a year, perhaps. That's breaking already, right? And 3 years from then, right, we're already starting to define Gen 3, the 800 volt architectures.
Yeah.
So my expectation is that, we'll see Gen 3 adoption, broadly speaking, over the next, 3 to 5 years, perhaps. As we look further out in time, I think some of the keynotes indicated this, as well as some of the folks that are on the expo hall. The Gen 4 architecture, I think, is really where we need to start paying attention.
And define Gen 4 for the audience a little bit.
Yeah, absolutely. So Gen 4 being basically removing the AC distribution throughout the data center, replacing that with 800 volt plus minus 400 volt, whatever DC voltage, and centralizing the AC DC power conversion within the data center's facility itself.
Yeah,
which is kind of a massive paradigm shift compared to how these facilities are architected today.
Oh yeah, huge.
Which it begs the question: does this mean that there's no longer 3-phase access for HVAC systems? So there's no longer lights, fire protection or suppressive devices, security systems. like it could change everything in regards to how these facilities are architected.
Yeah.
Which is something I think we need to start thinking about and talking about. Obviously, there are a number of folks that are presenting some of their solutions for technologies like solid state transformers this week.
Yeah.
But I think where I'd like to start paying attention to now is, what does this mean for the rest of the end equipments that reside within the facility?
Yeah, it's a huge topic. We're working with a bunch of the ODM on the, I would say, more industrial traditional power sense, the ABBs, Eatons of the worlds, and they're forming some work streams here at OCP and sub projects. And that is a big question that came up, is like, what about everything else? Some of it we can do, like we could do emergency lighting in DC because all battery powered.
Easy, yeah.
But there's other things, do you need 3-phase power for cooling? Are we going to DC motors? Like, what would you do? So yeah, there's a lot of, I think in this paradigm shift, as you described it, there's a lot of unknowns that we're not necessarily considering, because I think the industry's focused on these central challenges around AI, but to your point, like there's a lot of other things to solve.
Yeah, even like something simple like protecting the IT racks, right? You have relays today, right?
Yep.
Work great at AC. They don't work great at DC.
No.
You need solid state circuit breakers.
Right.
And perhaps like a 2000 amp solid state circuit breaker. We need the right silicon to go and support a 2000 amp circuit breaker.
Yes.
Right? Something that, I don't believe exists today. Yeah.
No, and definitely not at market scale.
Exactly, yeah.
Yeah, interesting. So what can people do? Okay, so we're like looking at both of our cloudy crystal balls, to understand like what a customer comes to you, like, what do you recommend to them? How do they stay flexible in their approaches? What can they do to anticipate the unknowns?
That's with my cloudy crystal ball.
Yeah.
So I would say that honestly, participate in OCP is probably the simplest thing that we can collectively do.
Well, I'm biased, but I appreciate that.
Yeah, I mean, honestly though, maybe less biased than you perhaps, but it's still, I think it's the best opportunity to talk to all of your peers that are likely navigating, the same architectural inflection points, and can use one another as a sounding board to figure out, what works, what doesn't work, and use that to then define, whatever the next set of standards need to look like. So that, I think there's an element of flexibility there, but I think and also an element of like compromising, determining, what is actually the best way to go about this.
Yeah, we have a track record. I mean, I think that's, we're here at our global summit and we have a record-breaking attendance, and I think we've seen that experience in other areas of the data center industry, and in some ways it's history repeating itself a little bit. It's just with a different technological challenge. Hyper focused on power.
Absolutely.
Being a big one. How about, join OCP, bring them in. Could you break it down specifically? Like, we have a lot of different types of people at these events, right? You have engineers, you have operators. What would somebody who's an operator versus an engineer, how would they approach this? How would they look at it? What do they need to be prepared for?
Yeah, well, I think it's important to, like, regardless of your scope or your personal responsibility, as it falls into the data center domain, to really understand the bigger picture. Right? So I personally learn a lot from, sitting in on like the public working group calls that are maybe not directly applicable to, TI and like the foundational semiconductors that go into the data center itself, but
interesting.
Provide you with a broader perspective of how like the rack level, like power densities increasing as an example, are affecting like the operator's life is another example, right? So I think it's honestly like OCP gives you access that I don't think any other consortium really does to the bigger picture and how it all fits together.
Yeah, I certainly agree. Do you have a favorite public project call that you like to join?
I like the rack and server power one.
Okay.
I'd say it's the most applicable. So I'm kind of selfish in that sense.
No, that makes sense.
I don't know. It's fascinating, getting an opportunity to look at like peers in the industry that have been doing this for decades, like share their open thoughts on challenges they're facing, what this means from a specification perspective. And it's impressive just the progress that can be made in like a routine monthly update,
Yeah. It's that, and I think we have a really strong group over there too, and they're very much tied in. And the rack and power area for OCP has, though we started with server, the rack and power, I think, have been very transformative spaces that have shifted, an entire industry.
Absolutely.
Right? Just from like rack widths, components that go into it, power distribution. Specific to TI, what I've actually seen some of your gear around the show. I've seen it over. NVIDIA has their MGX lineup. TI has product over there. You obviously have product on the floor. pieces and parts are you most excited about?
It's a tough question. I'll try to keep it brief, but
no, you don't have to.
Yeah, so I think most excited by really this shift to 800 volts. I think we started having these conversations maybe a year ago, and it was a real challenge to go and develop hardware in 12-month cycle time that is aligned with the direction of the industry. So I think it's been exciting to be a part of that journey and see these conversations in some of our customers' conference rooms on a whiteboard actually materialize in hardware that they plan to evaluate now
in like a year.
In a year, exactly. And so I mean, we're showing one of our it's a 30 kilowatt AC/DC power supply reference design that generates 800 volt DC or plus minus 400 volt DC off of a 3-phase AC input, which is new to my team specifically, as typically we've operated in the single phase AC domain. So that's been cool to be a part of. Really excited to be showing some of our like protection products alongside that. So demonstrating that we can use a native 48 volt component to basically protect an 800 volt system. We've got a reference design over there showing that as well. And then again, still in the spirit of power, but things are moving so quickly when it comes to like ASIC or XPU power demands, and we're showing off a lot of, I'd say, the more innovative like core power products. So 12 volt or 6 volt to 1 volt DC-DC converters to provide that 2 to 5 kilowatts that some of these XPUs are now demanding. And really, really tiny form factors. Like you see it on a slide every day, and you're like, 9 by 10 by 5 millimeters on a slide looks huge, and you see it in person, and it's a little fleck of sand in your hands. It's pretty remarkable.
And if you could make it smaller, they'd want you to make it smaller.
Absolutely. Smaller, faster, cheaper.
Yes, all the things.
Absolutely.
So what are most people, you described a lot of things around the power architecture, like in the rack. I think we're familiar with that. Like, what are people missing, like a bottleneck that you don't feel is obvious to the rest of the industry?
So I think we saw the introduction of, call it like a new classification of end equipments, maybe like last year, the year before last, which was, a capacitive backup unit or a power capacitor shelf. I think there's a number of different synonyms in the industry that exist. And, the intention of that is really to implement peak shaving, right, during heavy transient workloads. And I think a lot of customers have demonstrated that works great in a Gen 2 48 volt ecosystem, where that's actually, physically quite close to the transient source, quite close to the XPU.
Got like a super cap shelf, right?
Exactly. But now as we start to talk about this transition to 800 volts and the adoption of a sidecar, my question that I have yet to answer myself or reconcile myself is, how will that work in an architecture where your capacitor shelf is physically placed far away from the transient source?
Interesting.
You have all this additional inductance that's added in between the transient source, the backup unit. That's something that I'm hoping to learn today from some of our peers to figure out how do we solve that problem. Is that a problem? Maybe I'm totally incorrect, but that's something that kind of keeps me up at night right now.
No, that's a good one.
Yeah,
it's interesting. Like we talked about things that we don't know is going to be a problem, but you start moving things around in power. We already witnessed it. I draw a lot of parallels at OCP, especially with from power to liquid cooling. Right? 3 years ago, we started to see, I would say, a very similar shift to liquid cooling and all the challenges that created, moving from air to liquid and then direct to chip and all the piping and pieces and parts. And there were so many challenges that we didn't uncover until we started doing it. And I think things like that are going to continue to raise their head, that this is a problem. And
absolutely. And I mean, liquid cooling is an interesting too, in that they're becoming mission critical in the data center, right? If your XPU exceeds a certain temperature, it could fail. You could lose incredibly sensitive data. Maybe it's running a model that is like quite literally life-saving. Like it's becoming more important than it probably ever has in the past.
Oh yeah. I mean, if you were to take a air cooled anything and you lost cooling, I mean, you have capacity in the air for minutes,
right?
Potentially, but you lose it on a direct-to-chip loop. I mean, you're talking seconds,
exactly,
fractions of seconds, maybe,
exactly,
before you're, causing damage to the equipment itself, or just losing it in drop packets in the software.
Exactly.
And we're going to see that in power too. I'm sure. I mean, we already do. That's why we're trying. That's right. I guess maybe back to the original on the problem statement is why move to 800 volts? Like we have the demand, and I think there's other schools of thoughts. Like we talked about DC to DC for many, many years. on efficiency. Oh, you're just going to remove conversion, so we're going to gain 10-ish percent, 8-ish percent on power conversion. But that doesn't really seem to be the driver today.
Yeah, so I think it's a multifaceted response. So I think, one, your distribution losses, 800 volts, is less than 48 volts, right? I squared R, right? Or V times I, rather. So your V goes up, your I goes down for the same amount of power at the end of the day. But beyond that, more practically speaking, if you make the transition to 800 volts, you remove the AC, DC power conversion, you move the battery backup from your actual 42U cabinet.
Right.
You then open the door for, let's say, another 8 to 10U of available compute space.
Yeah,
so
that's a big one.
Yeah, so from my perspective, it's maybe less about efficiency gains, more about being able to fit more compute per square foot in the IT white space.
Yeah, I mean, very similar to the water challenge. Like one is chips are hotter and they're more dense, but the other is like I can't put heat sinks this tall on top of these chips. Like there's no room.
Exactly.
Yeah, it's interesting. Anything else you want to close people off with that say, here's what you should do, here's how you should get involved, how should they reach out to TI, what, connect it for them, and what should they do next? Yeah,
I think shameless plug again for OCP. I think
appreciate that.
Join, come participate, come talk to us next year at our booth. B, I would say, come visit our website, right? ti.com/data center. You can come check out our latest products.
Designs there?
We have reference designs, all of our data center products, really, hopefully every bit of information you could possibly need in order to, navigate that journey as you adopt next generation architectures.
Awesome.
And then reach out to your TI sales representative, or we'd love to work with you.
Excellent. Chris, thank you so much.
My pleasure.
Appreciate you being on.
Rob. Absolutely. My pleasure.
Yeah.